This question is about elements and compounds in group 14 or group 4 of the periodic table. Part A. There are 4 oxides of lead, PbO, PbO2, Pb2O3 and Pb3O4. A student carries out an experiment to identify an unknown lead oxide, which is one of the 4 oxides of lead shown above. The student plans to reduce the unknown lead oxide to lead by heating the lead oxide in a stream of methane gas, CH4. The apparatus is shown below. The student's method is that they're going to weigh an empty dish, add the lead oxide to the dish and reweigh, set up the apparatus and pass methane gas through the tube as shown, heat the dish for 10 minutes, pass cold air through the tube to cool the dish and contents, weigh the dish and contents. Part 1. Write the equation for the reduction of Pb2O3 with CH4. Let's firstly write our reactants, Pb2O3 plus CH4. We're going to produce lead, or Pb, and we're going to produce carbon dioxide, or CO2, and then water, or H2O. Then we need to balance the equation. So we're going to need 6 waters because we need 3 methanes. Because we've got 3 methanes, we need 3 carbon dioxides, and so we need 8 leads because we've got 4 lead oxides. So we can check this using what's called a list method. So if we write Pb, O, C and H for both sides of the equation, well, we've got 8 leads on both sides, we've got 12 oxygens on both sides, we've got 3 carbons on both sides, and we've got 12 hydrogens on both sides. So therefore we've balanced the equation. To get the mark for this question, you must have the correct balanced equation written on the answer line. Part 2. The student uses safety glasses and a lab coat. State with a reason one other important safety precaution the student should take when carrying out this experiment. For this question, there are 3 different options that would get you the mark, saying that compounds may be toxic, poisonous, flammable, all of those 3, and then you need to use a fume hood or fume cupboard. That gets you a mark, saying both of those things. Another way to get the mark is saying that lead compounds are toxic or poisonous, and so you need to wear gloves. This gets you another mark. Or saying that methane is flammable, so you need to keep away from fire. This gets you a mark. Part 3. The student was not sure that all the oxygen had been removed from the lead oxide. Suggest 2 modifications that the student could make to their method to be confident that all the oxygen had been removed. Explain your reasoning. There are multiple options that will get you a mark for this question. You can either say heat to a constant mass, break up or spread the lead oxide, pass the methane through the tube as it cools, use excess methane, or bubble gas through lime water. All 5 of these options would get you each a mark, so you just need to pick 2 of the 5 to get your marks for this question. Part 4. The student makes suitable modifications to the method and repeats the experiment to obtain the accurate results shown below. Calculate the empirical formula of the lead oxide. Firstly, let's work out the ratio of Pb to O. So we're going to work out O as the mass of oxygen that's left. So that would be the difference of these 2 masses. And that is 0.322. So what I've done is I've done 11.818 minus 11.496. That equals 0.322. Then working out the mass of lead, that would be the difference of these two. So that's 11.496 minus 8.364. That equals 3.132. So then we can work out the molar ratios by dividing by the relative formula mass. So that would be 3.132 divided by 207.2. And it's in a ratio of 0.322 divided by 16. So that turns into 0.0151 to 0.020125. So that is a 3 to 4 molar ratio, and that means that the empirical formula of our oxide is Pb3O4. You get the 2 marks for this question, one for working out the ratio and the second mark for working out the empirical formula correctly. Those 2 things gets you the 2 marks for this question. Part B. SiO2 and CO2 are oxides of other group 14 or group 4 elements. Solid SiO2 melts at 2156 degrees Celsius. Solid CO2 melts at minus 56 degrees Celsius. Suggest the type of lattice structure in solid SiO2 and in solid CO2, and explain the difference in melting points in terms of the types of force within each lattice structure. The structure in SiO2 is a giant covalent lattice, and in CO2 it's a simple molecular covalent lattice. In CO2 you have London forces, and in SiO2 the covalent bonds are stronger than the intermolecular forces in CO2, or the London forces. And therefore more energy is required to break the covalent bonds in SiO2 than is required to break the intermolecular forces in CO2. That's why SiO2 has a much higher melting point than CO2, where it's got a negative melting point. So to get the marks for this question, you get a mark for each correct structure. So giant and simple molecular, this gets you 2 marks, 1 for each. And then you get a mark for saying that there are London forces in CO2 and that the covalent bonds in SiO2 are stronger than the intermolecular forces in CO2. This gets you your 4th and final mark. So where the bullet point is, each other bullet point is a mark.